Let's move on then. Declaring an object reference of a variable, and basically, and remember that in your, if we were to go to lab 4, oh, well, it's not updated. This was updated. I don't know what's going on here. I definitely updated my web. So I don't know why this thing is. Okay. All right, I'm gonna have to look into that. That is definitely not right. Okay, well, let's go on here. Okay, so creating the object reference, and your lab 4 does tell you to do that. The object reference right here. So circle C1 is an object reference, so this might be a better one. Circle C2 is an object reference. That's an object reference right there. The class name space your object name. C2 is an object reference of circle. And we have that example there as well. Now, declaring, creating objects in a single step. So you can declare an object and create it in 2 different steps. So with circle 2, that's what I did. On one line, I declared it, and then on a separate line, I created it. And that's what lab 4 calls for you to do, by the way. Or you can do it all on one line. Either way works. Oh, someone. Okay. So on web access, it still has it. All right. Geez, I thought I spent time over the weekend and I thought I had it all synced. Not sure what happened. Of course, that's the wrong lab. That's the wrong lab 3. Okay, so it says create 2 bicycle references. That's going to be the same as this. Okay, 2 bicycle references. Got too many. Create 2 string references for the owner's name, 2 integer references. So I mean that's really the same down here. Be as simple as this. String name 1. That's a string reference. Integer reference. That's an integer reference. Just like this is a circle reference. This is a circle reference. It's all the same thing. Whether it's a built-in type or class or one you write yourself, it doesn't make any difference. It's all the same. That's actually one of the great things about Java. Now you can reference objects data directly. You shouldn't, but you can. And I think that may be why. Okay, so right now we probably, let me see if we can do that. Okay, right now I can access its data directly. And let's see what happens when I do that. Okay, it actually changed it. The problem with this is this violates a pillar of object-oriented program called encapsulation. which means properties or data are protected and controlled access is allowed. So the way, and we're going to get to this a little later on, but the way I would protect it is by calling this private. So if I put the private modifier in it, and now I go back to my test example, now I get an error message. Radius has private access. So it's telling me it's not going to work. If I try to run it, it'll give me an error. I get an error message. So now I can no longer do that because it has private access. And we actually want that to be the case. That's one of the pillars of object-oriented programming, actually. So we actually want that to be the case. So you don't want to do that. That's why we have methods, get methods, and we'll learn about a set method as well. So here's some more examples of constructing it. I don't know what this S circle, your circle equals new circle. So you can assign a value to it. This just goes through all the same stuff. And this shows how they're able to assign it directly, which is a really bad idea. And so also recall that like when we looked at the math class, that we were able to call variables directly. In order to do that, we cannot do that directly, and I'll show you why. So I can't say circle dot get area. It doesn't work. The reason it doesn't work is that area is what we call a instance method, which means it belongs to each instantiated object. Each house gets its own one. So if you call it from circle, how does it? That's kind of like saying going over to the blueprint, or maybe the blueprint, and saying what color is the bathroom. Well, we don't know because the blueprint doesn't specify that. Each house constructed from that blueprint has its own color. So we can't tell from the blueprint what the color is. That's what area is, because every circle has its own area. Now, we might be able to say from the circle, what's the value of pi? Because it's using pi in every instance. So, for example, let's say, and pi never changes, right? So let's say that and I'm going to go back to making this, get rid of it. Static means it belongs to the class, right? So what belongs to the class in a blueprint? Well, the square footage. Every house built from that house from that blueprint will have the same square footage, regardless. The bathrooms will have different colors and they'll have different carpets or hardwood floors, but every single one of those houses will have the same square footage. So if it belongs to the blueprint, i.e. square footage, then you can get it from there. If it's different with each house, the object, like the color of the bathroom or the carpets or whatever, then you can't get that from the blueprint. You've got to go directly to that house. So static means it belongs to the blueprint or the class. And I'm just going to call it pi is equal to that. Now I got to give it a value. I'm going to say double. Okay. So let's look at some of the things it does. Now, when I take C1 and I say here, I can see radius. Again. Can I get pi? I can. and I could do something with it. Print pi. Now we get a warning when we do that. It says you're accessing a static field from pi. Now, why is that a problem? It's not really a problem, but that's like accessing pi from a object of that class is like going to each house on the block that were made from the same blueprint and saying, what's your square footage? You get an answer. You go over to the next house and you ask the same question, what's your square footage? You get exactly the same answer because they were made from the same class. And again, you go down to every house in the neighborhood made from that blueprint and you ask all 200 households, what's your square footage? And you got the same exact answer all 200 times. The problem with that is that it's a complete waste of time, is the problem with it. It's not really wrong. If you want to waste your time like that, okay. But basically what this thing is saying is that, well, you can get the value of pi this way if you want to, but it's really more appropriate to get it directly from the class since it's the same for every single object, right? So I can say circle and get pi, no issue. But I can't say circle and get radius. That don't work. It says a non-static variable radius cannot be referenced from static content. Why? Because you can't go over to the architect of the blueprint and say, what's the color of the carpets on house number 4? The architect's going to be, huh? I don't know. Ask them. Yeah, you got to ask them. And that's the equivalent of the radius because it's different per object. However, you can ask the architect, what's the square footage? Because that's the same for every house. I hope that's making sense to people. The difference between objects and classes gets confusing. But if you're following the house example, hopefully that's helping. Any questions so far? All right. Reference data fields. Data fields can be of reference types. For example, a student class. Student class contains a data field name of string type. Right. So string, which we've used, but we haven't talked about a ton yet, is actually a class. It's an actual class, and it's treated like an object, but it's a special type of class that it's a class treated like an object, but it behaves or lets you use it like it's a primitive data type. Right? So string, int, boolean, and char. What's the difference between the four? Well, the difference is int, boolean, and char are all primitive data types. String is an object. A string is a class. Name is an object. Int is a primitive type. Age is a variable. Boolean is a primitive type. His science major is a variable. Sometimes these are called reference variables, but object is probably more appropriate. A data field of a reference type does not reference any object. A data field holds a special literal value null. Right, okay, that's true. So for most data types, what you're going to see is that these will have a default value of some value. Usually numeric data types will get a value of 0, if I'm not mistaken. We could leave this here and put no value in it and print it out. See what we get. And then down here we would have to assign the value. That should give us a default value of does not have a name. Okay, so the default value is 0, but it doesn't go to an exact 0 precision. And then we create it as that. Whereas a string at this time we could probably try and create lab4. Call this a bicycle. So this is lab 3, right? Okay. Bicycle. Which email I can get as well. Misspell it. So here it says, well, if we look at this here, these are both null. So let's do a similar thing in the constructor, and I'll say 2%s, %d. Let's do Sure no one's got any questions yet? And I'm just going to do part of these. Okay, so first it says create 2 bicycle references. I'm going to create the first one. And let's just go and run this. What we're going to see is nothing happens. Yep, nothing happened. So what I'm going to do is we're going to do this a little differently. Create the first bicycle constructor using the default bicycle constructor. So this will be bike1 equal to new bicycle. So when I run this, though, you're going to see this message here. And you'll see the value of null for owner name and then license number. And you'll also know that the constructor gets called here, not here. Right? Default constructor, null, and 0. So, in a long story sort of way, what we were saying was that null value is always assigned to all objects until they're given a value. And since we haven't given bicycle a value yet, it's null. Okay? The data field holds a special literal value. No. Once you give it a value, then it gets that value. And I'm not going to go through these ones per se, but let's just say, I'm just going to pull this out. Well, we can leave it here. And we'll also leave it here. Now this doesn't work because these fields don't exist. But you have to do, just like we did with area, bike1.get owner name. Okay, so we'll do that part. Now I'm going to show you this part here. That's still going to be null. Use the setters. Bike1.set license number 1, 2, 3, 4, 5, 6. And I'm just going to say Kenny. Then again, we'll print this out. Okay. Okay, default constructor null null. It should be default constructor. It should just say values null and 0 again, or null and 0, null and 0. And then after I call the set methods, now I've got some actual values in there. Okay. And this also gives you an idea of how to do it. Create the bicycle reference. Construct the bicycle from the default constructor. Use the setters to give the values. And print it out. I'm not going to go through their example. We already see this example. And we already looked at that it's got no value. It's going to show you null. So primitive type I gets a L automatically. C is a reference variable. All objects are reference variables. Okay, any questions?